Hi there! You probably know that in life, it is more important to be logical when solving a problem rather than being book smart. SAT reasoning questions test for such skills, logical skills. This is good news because you get to create your own method. And your school math program from 5th grade till Algebra 2 has given you the tools. All you need to do is to figure out which tools, where, and how. So what are the tools? Tools are charting, organizing the data, equations, diagrams, formulas, etc. Logic is when and where you can apply the tools. To help you, I have come up with a 5-step thinking process. Step 1. Gather the information. And when you're gathering the information, do not try to solve the problem. Step 2. Identify the tools you may need. Do not worry about whether your tools are helpful at this stage. Step 3. Identify what the question is asking. This means rereading the question. Step 4. Try and connect the tools you gathered to what's being asked. Step 5. If you cannot find a way to solve the problem, make your tools simpler. Let's go ahead and do some problems now. Let's gather the information. The largest number in a series of consecutive even numbers, so I want to underline consecutive. The word consecutive is very important, so we want to underline consecutive even integers, and that is W. So you could have 2 consecutive even numbers, and the last digit is going to be W. That's what I understand. If the number of integers is P, so in this situation, P is equal to 2. What is the smallest number in terms of W and P? So I'm not interested in answering the question just yet. I want to gather information as much as possible and see if I can find any tools that I've learned from 5th grade through to Algebra 2 that may help, starting with even recognizing patterns. So I'm going to go ahead and put 3 consecutive even numbers, and that number will be W, and P here is 3. What about 4 consecutive even numbers? And that is W. And my P is 4. We'll try one more. 3, 4, 5. So P is 5. And my last digit is W. Going back to the question, what is the smallest number? So they're asking for this number here. 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 To get to this number, I have to say W minus 2 because it's consecutive even. To get to the smallest number here, I have to say W minus 2 twice. So here it'll be W minus 2 times 2. So it would be W minus 2 times 3. So we have W minus 2 4 times. Let's just say 1 here because P is 2 and there's only 1 here. So let's just say 1. So you can see that the number in the parentheses is 1 less than P. This one is 1 less than the corresponding P. Number is 1 less than corresponding P, and the number here is 1 less than corresponding P. So it looks like the answer should be W minus 2 times P minus 1, and the correct answer is C. Let's go ahead and look at this problem. Henry and Eleanor are waiting in line for a movie. If Henry is 4th in line and there are n people ahead of Eleanor, where n is greater than 4, how many people are between Henry and Eleanor? I'm not interested in answering the question just yet. I want to gather my information and figure out what tools I'm going to use. I can already tell that I'm going to draw a diagram here. So there are 4 people. So 1, 2, 3, 4. Let me double check. Henry is the 4th in line. So 1st, 2nd, 3rd, 4th. So this is Henry. And there are n people in line ahead of Eleanor. So Eleanor might be here somewhere, and we don't know. And there are n people ahead of her. So that's gathering information here. So how many people are between Henry and Eleanor? Between here and here. Should be n minus 4, right? The answer is B. Here's a good one. It's all about logic. During a season in a certain basketball league, every team plays every other team in the league 10 times. If there are 10 teams in a league, how many games are played in the league in one season? So there are 10 teams. So each team can play the other only 9 times. And they played 10 times. So 9 times 10 would be 90 games. So each team plays 90 games. Since there are 10 different teams, then there would be 900 different games. But watch out. If Team A plays with Team B, that means Team B is playing with Team A. So actually, there are half as many games. There are 450 games. Think about it. Since each game is counted twice, because Team A playing with Team B is same as Team B playing with Team A, we have to have the number of games, and the answer is C. At a certain factory, 5/8 of the workers are married, and 3/4 are at least 40 years old. If a quarter of the married workers are younger than 40, what fraction of the workers who are at least 40 are not married? So we have a lot of information here. I want to organize and collect my data. So I have at a certain factory, 5/8 of the workers are married, and there are some married and some unmarried, and some under 40 and some over 40. And they're all fractions. I look at all the denominators. I want to pick a number. If it was a percent problem, I would pick 100. But I want to pick a number that 8 and 4 will go quite nicely. And let's just say I picked 32. So now 5/8 of 32 workers are married, and 3/4 are at least 40 years old. So let's see. How many are married? So 5/8 of 32. So that would be 4. I would say there are 20 married. And 3/4 are at least 40 years old. So 3/4 of 20. So I would say 1 4s are 4, 5 4s are 20, and 15 are at least 40 years old. So since I know there are 20 married altogether, and that leaves only 5 married that are under 40. If the quarter of the married workers are under 40, which we already have, what fraction of the workers are at least 40 and not married? So we know we have a total of 32. We assumed a total of 32. The next piece of information is 3/4 are at least 40 years old. So let's go ahead and figure out 3/4. So 3/4 of 32. And if you reduce this, 8 3s are 24. So you will have combined, you have at least 24. That must mean that you have 9 unmarried. So the question is, what fraction of workers who are at least 40 are not married? That is 9 who are unmarried and 24 who are 40 or older. So 9 over 24 reduces to 3/8, and that's your final answer. There are 7 people on Committee A and 8 people on Committee B. If 3 people serve on both committees, how many people serve on only one of the committees? So 3 people serve on both the committees. So let's put 3 over here. And there's 7 in A, so that makes 4 here. And let's put 5 here. 5 plus 3 is 8, and there are 8 people. Let's look at the question. How many people serve on only one of the committees? It's 4 plus 5, and the answer is 9. Okay, I now have some exercises for you. I would like you to pause the video and try and answer this question on your own, and then run the video for the answers. A picket fence is composed of X pickets, each of which is 1/2 inch wide. So I have X pickets, 1/2 inch wide. If there are 6 inches of space between them, and the number of spaces is 1 less than the number of the pickets, so you have to add 6 times number of pickets minus 1. So doing your due diligence here, distributing the 6, collecting your like terms, you come up with 13 over 2x minus 6. Remember, they're asking in feet, so you have to divide by 12. So the final answer is 13x over 24 minus 6 over 12. And you find that that's not given in the answer choice, so you have to recognize that 6 over 12 is same as saying 12 over 24, and the correct answer is E. Okay, I have one more for you to try. Please pause the video now and try this problem. When you are ready, run the video for answers. Let's look at the problem. Poplar trees are planted on both sides of a straight street for a length of 3/8 of a kilometer. Each tree is planted in a plot that is 1 meter wide. So here's your plot, which is 1 meter wide. And there are 16 meters apart, or 16 meters of space between the adjacent plots. So altogether, they have to be 17 meters apart. So let's go ahead and gather some information here. 3/8 of a kilometer, we are asked what is the maximum number of trees lining the street, and let's work in meters. So 3/8 of a kilometer turns out to be 375 meters. Simplify my problem to the very basics. So here's the beginning and here's the end. And we have to pack in as many poplar trees as we can, provided they are 17 meters apart. Here's my first tree, and then 17 meters apart is my second tree. So in 375, how many lots of 17 meters can I pack in? And it looks like I can do 22 with the remainder of a meter. Let's think about it. 22 poplars with the remainder of a meter. You don't really need the space after the last tree. So I could add in another tree here and make it 23. So 374 meters could contain 22 plots and the spaces between them. And then there is one more plot in the last meter of space for a total of 23 poplars on each side. Since there are poplars on both sides of the street, we can fit 46 poplars in all. So be very careful about doing simple math and coming to a conclusion. Remember, the question said that the number of plots are followed by a space, but there is no need for a space after the last plot. They did not say that. There is a space only between pairs of plot. Since there's no plot after the last one, there is no need for a space there. Okay, this ends my session. Thank you very much for listening, and I'll see you again. Goodbye.